So in our lesson today, we're going to actually solve exponential and logarithmic equations. Obviously, our essential question is how can you solve equations that model the growth and decay, and that's what logarithmic and exponential equations are. And then our learning objective is to solve them. So an exponential equation is an equation equation containing one or more expressions that have a variable as an exponent. So this is exponential equation. Whoa, something's weird. Yeah, I'm not sure what's going on up there, y'all, but this is exponential equation. That's what the first blank is, or first two blanks, I should say. So an exponential equation is an equation containing one or more expressions that have a variable as an exponent. So to try, when we try to solve them, basically, we're going to write them so that the bases are the same. So notice here that we have the base b to the x power and the base b to the y power. Obviously, then the x has to equal y. If the bases are the same, then whatever's in the exponents have to equal each other if the two equations are equal to each other. So the next one says take the logarithm of both sides. So if a equals b, then the log with the same base of a equals the log with the same base of b. So this log base 10, right? Because there is no base. So as long as the base is the same here, a has to equal to b. Okay? So that's what we're going to do for these next set of problems. So we're going to round these to 3 decimal places if needed. So example 1 says solving exponential equations. So on this first one, we want to get the same base. So I'm thinking what number goes into both of these, and I know that they both have a 3. So I'm going to go 3, and 9 is 3 squared. So then I'm going to multiply that times R8 minus x. And then over here, 27 is 3 to the third, right? So what we're trying to do is get the same base here, that 3. And then that's going to be x minus 3. So our goal, once again, is to get the same number here, okay? So once we have that, then we can take what was up here and set it equal to each other because we have the same bases. So this is going to be 2 times 8 minus x is equal to 3 times x minus 3. So I'm going to go ahead and multiply this. So this is going to be 16 minus 2x equals 3x minus 9. I don't like dealing with negative x's, y'all, because I know for you guys sometimes it causes an error. So I'm going to add 2x to both sides. And at the same time, I'm going to move that 9 to the other side. So that gives us 25 over here. That's gone, right? And that's equal to 5x. And this is gone. So then we're going to divide both sides by 5. So x is going to be equal to 5. Now we can check this by going ahead and putting that back up in. So that's 9 to the 8 minus 5. So that would be 9 cubed. And then over here, is that going to be equal to 27 to the, again, 5 minus 3, which would be 27 squared. Well, when I take the, when I cube the 9, I get 729. And when I take 27 squared, I get 729. So that means my answer does check out. So there's, you guys can check your answers on these problems. And when you can do that, you should do that. All right, so the next one, because we have the same basis here, this is what we just talked about, that means we can then just take our exponents and set them equal to each other. So that's what we're going to do. I'm going to subtract that 3x from both sides again, and I'm going to add that 8. So now that's gone from there, and I get 4 here, and then I get 2x here, and that's gone from there. So now we're going to divide both sides by 2. So x is equal to 2. So here again we got e to the 3 times 2 minus 4. So that's going to be e to the 6 minus 4. That's e to the second. And we want to know, is that equal to e to the 5 times 2 minus 8? So that's 10 minus 8, which is also e to the second. So here again, the answer checks out. Now with these, this is kind of like the part B up there where it said log base A equals, okay, so what we're going to do, we're just going to put this in log form, okay? So we're going to say the log of our base, which is 4, is equal to what's on the other side, is equal to the exponent, okay? So this is the same thing we've been doing all along, only now we're going to use the change of base formula. So this can be log of, remember we're putting the 5 on top, and we're putting our base in the basement, right? So now when you do this, I wouldn't round to the end, okay? So I'm going to emphasize that with you guys as we work through these problems. So when I found this, I got 1.16096 ... right? Okay, and that's equal to x minus 1. Well, our next step would be to add 1. Now I'm going to just leave this number over here on the left in the calculator. And I'm going to add 1 to both sides. What am I doing? Sorry. I'm going to add 1 to both sides. So that's going to give me 2.16096 ... And then my answer, we're going to round to 3 decimal places. So that's going to be x is equal to 2.161. And again, you can put that up here and see if that gets you the same answer, and it does. You should get 5 is equal to 5, and it checks out, okay? So how do we get rid of an e, guys? Hopefully y'all remember this. So we're going to say ln of e equals 2x plus 7 equals ln of 14. So these two cancel each other out, so we're going to end up with 2x plus 7 equals, the ln of 14 was 2.6391 ... right? So we're going to subtract 7 from both sides. So that's going to give us 2x is equal to negative 4.3609, again, ... and then divide both sides by 2. So x is equal to negative 2.180 is what I got when I rounded it. Again, you can plug it up in there to check it, okay? And what you should get when you check it is that 14 is equal to 14, okay? So this one, I want you guys to go ahead and try this. Come back to me when you're done. Just keep in mind that you want to get the same bases, okay? So this is going to be 3 to the 2x is equal to 3 to the third. Now we have the same basis, right? So we can just say 2x equals 3. So x is equal to 3 over 2, which is the same as 1.5. Again, you can plug it back up in there to check it, which would really be 3 to the 2 times 3 over 2, which means those two are going to cross each other out, which is 3 to the third, which is equal to 27. So yes, 27 equals 27. Okay? On this one, we're going to have to use our log again. So what's the base? We got log base, and you guys should be doing this on your own, but I'll take you through this first step. 7. What's on the other side of the equal sign? 21, and that's equal to negative x. We're going to use the change of base formula to solve this. So we're going to do, remember, the base stays in the basement. So log of 21 over log of 7. That's going to equal our negative x. So when we do this one, we're going to get 1.5646 equals negative x. So we can either divide or multiply by negative 1. So that's just going to make our whole term negative. So it's going to be negative 1.565 equals x. Again, plug it up in there, which would be really positive. It's going to end up being positive. So it's going to be 7 to the 1.565. That gives us approximately 21. Here again, this one, we're going to have to use our log. So we're going to say log base 2 of 15 is equal to 3x. So we're going to do the log of 15 divided by the log of 2. That equals our 3x again. Divide log 15 by log of 2, and when you do that, you should have got 3.9069, and that equals 3x. And again, it keeps on going. I just do that and leave it in my calculator. And then I divide both sides by 3. So that gives me 1.302 when I round it, equals x. And once again, I can put that up there, and if 15 equals 15, then I got the right answer. So on this one, we're going to use our ln again. So we're going to say ln of e to the 3x minus 2 is equal to ln of 26. So these guys cancel each other out, so we're left with 3x minus 2 equals, I got 3.2581. I'm taking it to the fourth digit just because you can see it, because obviously on your calculator, I don't want to round till the end. So then I'm going to add 2 to both sides. So that's going to be 3x is equal to 5.2581. 8, 1, dot, 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 right? Then we're going to divide both sides by 3. So x is going to be equal to 1.753 when I round it to the third decimal place, okay? So now on the back, now we're going to talk about a logarithmic equation. It's an equation with a logarithmic expression that contains a variable. So we're going to write logarithmic here. Logarithmic equation. So you can solve logarithmic equations by using the properties of logarithm. So if log base b of x equals log base b of y, then x equals y. So notice that these have the same basis. Also keep in mind, since we cannot take the log of a negative number, we must check for extraneous solutions when solving logarithmic equations, okay? So on this first one, we're going to take it from logarithmic form to exponential form. So we're going to say 6 to the negative 1 is equal to 2x minus 1. Well, 6 to the negative 1 is 1/6, and that's equal to 2x minus 1. I'm going to add 1 to both sides, and some of y'all would do this in your calculator. I get that, but again, when you round it, don't round it till the end, okay? So I'm going to add 1 to both sides, and the way I'm going to do that over here is I'm going to do 1/6 plus 6 over 6, because that's the same as 1, right? So that's going to be 7 over 6 equals 2x. How do I get rid of the 2, y'all? Yes, we could divide by 2, but we can also multiply by 1/2, which is going to be easier in this case, right? So that's going to give us 7 over 12 is equal to x. Now when we check this, okay, so this is the way we're going to do it. We're going to do log base 6 of 2 times 7 over 12 minus 1. Okay, so this is going to be log base 6 of, that's going to be 14 over 12 minus 12 over 12, which is going to be what? 2 over 12, which is the same as 1/6. And that's going to equal negative 1. So this is really going to be log base 6 of 1/6 equals negative 1, right? And that's true, because why? 6 to the negative 1 equals what? 1/6. Y'all see that? So this is the correct answer right there. We checked it. Okay, so down here, again, 5, take our base to the opposite side to the 8th power equals x to the 4th. 5 to the 8th power is 390,625 to the equals x to the 4th. Remember what we do here. We take the inverse, or the reciprocal, which is 1/4. So this is going to be, sorry about that, y'all. So this is 25 is equal to x. So again, if we do log base 5 of, 25 to the 4th, that's equal to 8. So we're really looking at what? Is 5 to the 8th the same as 25 to the 4th? And obviously the answer to that is yes, because we had this number here, and 25 to the 4th, if you take it, you'll see that it is also 390,625. So this one checks out as well. All right, so now this one's a little different, okay, guys? So, excuse me, when we do this problem, we're going to condense, okay? So we're going to take our log base 4, and remember, if we have a minus, we're going to do 100 over x plus 1, right? And that's equal to 1. Now we're going to put it in logarithmic form. Excuse me, so that's going to be 4 to the 1st is equal to 100 over x plus 1. So that's 4 is equal to 100 over x plus 1. How do we get rid of something in the denominator? Yes, we multiply both sides by it. So that's what we're going to do. So that's going to give us 4x plus 4 is equal to 100, because what happened over here is these two things canceled each other out, remember? So then we're going to subtract 4 from both sides, so 4x equals 96, and then we're going to divide both sides by 4, so that's going to be x is equal to 24. So once again, we're going to check this. So we got the log base 4 of 100 minus the log base 4 of 24. plus 1 is 25, right? And that equals 1. So you can do that in your calculator, and you can do it by doing log of 100 divided by log of 4 minus log of 25 over log of 4, and that does equal 1. So 1 does equal 1, okay? So remember, you always got to check these. All right, so this time we have a log base 10 is equal to a log base 10. So these are the same, right? So I said when they're the same, we can just set these equal to each other, right? Now, my first period class was not happy with me when we did this one because I said we're going back to factoring. Okay, so what we're going to do is we're going to subtract the 4x and the 14. And we're going to move everything to one side of the equal sign. So, right, so we're going to have x squared minus 4x. 2 minus 14 is minus 12. Then we're going to have to factor this thing. Okay, so we're going to have x and x. What are the factors of negative 12 that when added together give you a negative 4? Hopefully you remember it's negative 6 and plus 2. Then we're going to set each of these equal to 0. So x is equal to 6 here. Okay, so now we have to check both of these, remember. So what we're going to do is we're going to say the log of 6 squared plus 2, does it equal the log of 4 times 6 plus 14? Whoa, I made that ugly. That was a 2 up there. So 4 times 6 plus 14. So this is actually 36 plus 2, that's 38. So this is the log of 38. And that's 24 plus 14, that's also 38, right? So we know those are equal, okay? Let's check our negative 2. So now we got the log of negative 2 squared plus 2. That's going to be the log of 4 plus 2, because negative 2 times negative 2 is 4, right? So that's going to be the log of 6. And then is that equal to the log of, again, 4 times negative 2 is negative 8 plus 14. Negative 14 minus 8 is also still 6. So both of these check out. So these are both answers, y'all. Both the negative 2 and the 6 for this problem. So our next one, we're going to condense first. Remember, ln just means log, so we can condense this. So this is ln of what? X times x plus 1. And that equals ln of 2. So I'm going to have ln of x squared plus x equals the ln of 2. Remember that ln still just means log, right? So that means I can take that away. Sorry, not the equal sign. Bad. I can take the ln away, and I can say x squared plus x equals 2. So that's going to be x squared plus x minus 2 equals 0. Again, we're going to factor this. So what are the factors of negative 2 that add up to be positive 1? So that would be positive 2 and minus 1. I'm going to set each of these equal to 0. Okay, now we have to check both of these. So notice up here we have the ln of x, right? So when we do the ln of negative 2, we're going to get an error message, okay? Because we can't take the log of a negative number. So this answer right here is invalid. Now when we do the other one, we put 1 up here. So if we put 1 here and we put 1 here, so we're going to take the ln of 1 plus the ln of 2, we're going to get the ln of 2, okay? So, and you can figure this out by literally doing 1 times 1 plus 1. You can put it right here as well. So this would be 1 and 1, so this would be 1 squared. So that's 1 plus 1 is 2, right? So ln of x squared plus x is equal to 1 squared plus 1, which is 2, so the ln of 2 equals the ln of 2. So over here, we're going to move this first. Remember, we can use all our properties. So we got ln of 3x minus 4 is equal to the ln of 3 to the 4th. again, we can take those away. So this is 3x minus 4 equals 3 to the 4th, which was 81. We're going to add 4 to both sides. So 3x equals 85. Divide both sides by 3. So x is equal to, I got 28.333. Okay. If you put that number back up in there, you will see that it is indeed the same. And so this one checks out as well. All right, so this next one, again, we're going to condense first. So this is going to be 3 is equal to the ln of what? 9. Let's do this first, actually, and make that plus the ln of x to the third. Then we got 3 is equal to the ln of 9 times x to the third. So this is 3 is equal to ln of 9x to the third, right? Now we're going to take this to the e. So e to the third was, trying to see where I'm at, y'all, on my paper. So this was 20.0856. I'm just taking it to the 4th digit for now, and that's equal to 9 to the x to the third. So, and I think on y'all's paper, actually, that was an 8, wasn't it? Yeah, I remember that now. So this is an 8, guys. Sorry. So we're going to divide both sides by 8. And that's going to give us 2.51069. I'm just going out, and then that's going to be equal to x to the third. So how do we get rid of a third power? We take it to the 1/3 power on both sides. So x is going to be equal to 1.359. And again, plug it back up in there and make sure it works. It does, but just make sure. So on this next one, we're going to condense first. So I'm going to say log of x squared minus log of 4 equals 0. Then I'm going to keep condensing, so I'm going to say log of x squared divided by 4 is equal to 0. Now I'm going to put it in exponential form. So I'm going to take my base, 10 to the 0 is equal to x squared divided by 4, right? So that's going to be 1 is equal to x squared divided by 4. We're going to multiply both sides by 4. That's going to be 4 is equal to x squared. So then we're going to take square root of both sides. So that's going to be x is equal to plus or minus 2. Remember, anytime you take a square root, you have a plus or minus. So now let's go ahead and plug these answers back up in here. So if we do 2 log base negative 2 minus log base 4 of 0. So when we do put this negative in here, we're going to get an error. Whoa, we're going to get an error, okay? Because remember, we can't take the log of a negative number. So that means we're going to eliminate the negative. Let's go ahead and put the 2 up there. So then we're going to do 2 log base 2 minus log of 4. And remember, this is really what? Log of 2 squared minus log of 4. That equals 0. So this would be the log of 4 minus the log of 4, which obviously going to be 0. Okay?